In two previous chapters, we talked about numbers that represent parts of wholes. Fractions represent parts of wholes, we said, and decimals also represent parts of wholes. In this chapter, we're going to study another way to represent parts of wholes, and that is by using percents. The main interest that we have in this section is to interpret percent and allow ourselves to convert numbers from a percent form into a fraction form, into a decimal form, back to percents. You see, all of those need to be pretty much interchangeable in our thought process. Well, percents can be thought of as meaning parts of 100. In fact, there's a great illustration in your textbook to show this parts of 100 idea. There's a big square, and then there are a bunch of little squares. There are actually 100 little squares inside the big one. And 13 of those little squares are shaded. And so the illustration is to represent 13 parts of 100, or 13%. And another interpretation of percent is that percent means hundredths. So if we realize that percent means hundredths, or percent means parts of 100, then we can convert percent numbers to decimals and fractions. Let's talk about converting 13% into a fraction form. Here's what we would think. And by the way, there are several right ways to do this, and I want you to know that. There's no one way that is right and every other way is wrong. So be comfortable if you see another way to approach these same problems. But here's one way. 13%, and this is what you would write down. You say, all right, I have problem number one. This is 13%. I want to change into a fraction. Percent means hundredths. You see, are parts of 100. So this is 13, and replace percent with a hundredth. Percent means hundredths, you see. And now just multiply as we understand. This is 13 over 1 times 1 over 100, multiplying straight across. 13 times 1, 13. 1 times 100, 100. So the fraction corresponding with 13% is 13 hundredths. Now, let's just think about this and think about this just for a moment. That we say that percent means hundredths. So suppose we just replace percent with the word hundredths and read this that way. That is, read 13% as 13 hundredths. We are reading this fraction, you see. And that's a perfectly good way to approach it as well. All right. So 13 hundredths is the fraction. For the next one, 25%. Again, it's like, okay, here's problem number 2. So 25% means 25 times 100th. That's the safest way to approach these problems. So this is 25 over 1 times 1 over 100. We could cancel right here if we see that opportunity. If we don't, it's okay. Multiply straight across. 25 times 1 is 25. And then 1 times 100 is 100. And now we certainly would want to reduce. 25 and a 25 goes one time. 25 and a 100 goes 4. So this is the fraction 1/4. So 25% then is 1/4. Now, if we used the idea on this problem, like I mentioned before on this one, that if we read this as 13 hundredths, then we have the fraction. If we read this as 25 hundredths, then we get 25 over 100, which then would reduce to 1/4. So we could use that strategy if we want to. 120%. Wow. Now this one, maybe they start to look strange or something like that, and we are using a particular strategy on the easy ones like this, and the fractions come out real nice, but we're not sure of what to do in situations like these two. Well, just go back to the fundamental idea of the meaning of percent. You know, percent means hundredths, so let's go through that kind of strategy, and we would take the 120% and we would write 120 times 100th, you see, or 120 over 1 times 100th. And once again, we could look for this cancellation. There is a nice cancellation here if we want to take advantage of it, but we really don't have to. We can go straight across. 120 times 1 is 120, and then 1 times 100 is 100. And now there are several ways to approach this. We could say this means 120 divided by 100. Let's go through the division. That's one way to think about it. So 100 then into 120. Gee, that goes one time. 1 times 100 is 100. Subtract, we get 20 as the remainder. 20 is the remainder, 100 is the divisor. put the remainder over the divisor, and now we have a mixed number. We would want to reduce the fractional part, certainly. So this becomes 1 and, let's see, 20 into 20 goes 1, 20 into 100 goes 5. So this is 1 and 1/5 as a mixed number. All right, so let's go over here and write that in. All right, 1 and 1/5. Now this one kind of looks strange, doesn't it? It's got a fraction involved in it, or we have a mixed number with the percent symbol following it. What are we going to do? Well, we're going to do the same thing we did before. We're going to think of this as 12.5 times 1 over 100. You see, and just kind of follow our nose with what we understand about this, finding this product. 2 times 12 is 24 and 1 is 25. So this is 25 halves times 1 over 100. Let's take advantage of the cancellation here. 25 into 25 goes 1, 25 into 100 goes 4. And now multiplying straight across, 1 times 1 is 1, 2 times 4, 8. So the fraction corresponding with 12.5% is 1/8. Let's change percents into decimals. Now we're going to use exactly the same strategy, it turns out. To change 15% into a decimal form, we think about, let's see, 15% means 15 parts per 100. Let's see, parts of 100. Now, I want to think about it in a way that I can multiply here. You see, so ponder it a little bit, and it's 15 hundredths, just like we had before. 15 times 100th is just fine. So it's 15 times 100th in decimal form this time, though. You see, would be this. And now when we multiply, and I'll show the multiplication in this one, but we're going to have a shortcut here in just a minute. So 1 times 5, 5, 1 times 1, 1. There are 2 digits to the right of the decimal above this line or in these factors, and so we need 2 digits to the right of the decimal in the answer. Counting off from the right, 1, 2, the decimal belongs here. So here is the decimal corresponding with 15%. So 15% is 15 hundredths. No surprise there, is it? 15% is 15 hundredths. You see, by replacing the word hundredths with the percent business, we are saying the decimal that we convert to. For this one, 45%. Percent means hundredths, so this is really 45 hundredths. So 45 hundredths. You see, and we can just write it right down in a lot of cases like this. Another way to think about it is this way, that really in changing a percent number into a pure decimal, all we're doing with the digits is we're taking the decimal point, which is understood to be here, and notice where it ends up. It ends up 2 places to the left, and we drop the percent sign. Percent means hundredths. Dividing by 100 means slide the decimal 2 places over. You see, so that's really all there is to it as well. Let's use that strategy on the next one. We're just converting 3% into a decimal, and we think about moving the decimal point 2 places to the left. The decimal point in 3 is understood to be here. When we move 2 places over, we need a placeholder. So let's see, we'll have a decimal, a 0, and a 3 when we make the conversion. So 0.03, and it's customary to write a digit 0 to the left of the decimal as well. All right, in this one, same idea. The decimal is going to move 2 places to the left. So we go 1, 2, and we need a placeholder for that second digit to the left. So it's 0.062, and let's tack on this 0. So that's all there is to it. All of these correspond now with the idea of percent meaning hundredths. We're multiplying by 1/100th in order to change the percent to a decimal. On this one, again, we're just moving that decimal point, and we move it 2 places south. So we go 2 places to the left. Gee, we need a placeholder in here. So we need a 0, and we already have this 0, so it's the 0 that we added, the 0 that's there, the 2 and the 5. So here is the decimal version of that percent. Let's go the other way. Let's change decimals into percents. You see, now, it would be no surprise if we said, well, gee, if we just move the decimal point in this idea of changing percents to decimals, we just move the decimal point a couple of places. Doesn't it make sense that if we're going in the other direction, we move the decimal point in the other direction? Yeah, that makes sense. But there could be some confusion. We don't want to memorize a skill like that. Because what if we move it in the wrong direction, you see, and we're not sure whether it makes sense to move it in this wrong direction? You see, then we could get ourselves in trouble. So we need to have some fundamental idea, at least at first, of what's going on here. So what we're in changing this into a percent, here's how we can think about it. It's really 45 hundredths times, and here's a strategy that works out, times 100%. Now 100% of something is all of it. It's like multiplying by 1. In fact, let's verify that. Let's think about 100% for a moment. And I want to change the percent into a decimal, let's say. The previous problem. Change the percent into a decimal. The decimal point is understood to be here. Move it 2 places to the left. You see, then we have 1 decimal 00, or simply 1. So 100% is 1. So in multiplying by 100%, we're just multiplying by a form of 1. And multiplying by a form of 1 will change the appearance of a number, but it won't change its value. All right, so we're multiplying by 100%. Now, we multiply 100 times 0.45. Remember, in multiplying by 100, the decimal point slides 2 places to the right. So we have 45, and that's just bring down that percent sign. You see, so it gives us the notion, and it follows what we learned before, that if we are changing from percent to decimal, we move the decimal point to the left 2 places. If we're changing from decimal to percent, we move the decimal point 2 places to the right and tack on the percent sign. So that's the idea. But in all cases, we can think about this notion of multiplying by 100%. And let's do that here. Let's do that in a few of these problems. So 45 hundredths, hundredths means percent. 45 hundredths is 45%. All right, 72 hundredths should make some sense that it's 72%. We can verify like this. Just multiply by 100%. Multiplying by 100 slides the decimal 2 over. Bring down the percent sign, and we're finished. This is 72%. For the next one, 1.35, or 1 and 35 hundredths. 1 and 35 hundredths. We may be confused about what we need to do. We may not remember that we need to move that decimal 2 places to the right and tack on a percent sign, which is all we really need to do. If we don't remember that, then we think about 1.35 times 100%. Oh, 100 times 1.35, decimal moves 2 over, so we have 135 and bring down that percent symbol. So this means 135%. All right. Same idea with these. 2.4, 2 and 4/10. Slide that decimal 2 places to the right and tack on a percent sign. That's all we need to do. So slide over 2 places. We need a placeholder for the second position. So it's 240%, 240%. For this one, slide that decimal 1 2 places over, corresponding with the idea of multiplying by 100, you see, and tack on that percent sign. So it's 0.5%. To change fractions into percent, we can approach these situations in much the same way. That is, we can multiply by 100% if we want to do it that way, and I think we do. That changing 1/2 into percent is 1 times 100%. Now, think of it this way, and we think of 100 over 1, you see, for multiplication purposes. The 2 into 2 goes 1, 2 into 100 goes 50. So this is really 1 times 50 is 50. 1 times 1 is 1. So this is 50%. So 1/2 is 50%. That's a good way to go through the process because we have a manipulation that we're very familiar with, that will get us into this percent world. All right, so let's go through it again. We have 2/5. We want to change to a percent, so it's 2/5 times 100%. So that's 100 over 1, you see, percent. And now away we go. We'll look for cancellations. Oh, we see one here. 5 into 5, 1. 5 into 100 is 20. And 2 times 20 is 40. So this is 40%. So 2/5 corresponds with 40%. One and 7/9. 1 and 7/9 as a percent. Let's do this one over to the left. Now, and I'm going to do it over to the left because there's a little more manipulation to it. But it's the fundamental idea is 1 and 7/9 times 100%, which we think of as 100 over 1 in a fraction form in percent. And we're doing this and we're just tacking on that percent sign. Now, 9 times 1 is 9. 9 and 7, 16. So this is 16/9, you see, and times 100 over 1%. And now we would look for cancellations. Gee, I don't see any. So it's 16 times 100, and that turns out to be 1600. 9 times 1, 9. So it's this percent. Well, I don't like that. We want to put this in a more palatable form. This is an improper fraction situation. So we would probably go through the division process to make the change. So it's 1600 divided by 9. Oh, that's 9 into 1600. 9 into 16 goes 1. 1 times 9 is 9. Subtract, we get 7. Bring down the 0. 9 into 70, let's see, goes 7. 7 times 9 is 63. Subtract, I get 7. Bring down the next 0. Gee, I had 70 up here. I have 70 here. We know what's going to happen. We're just going to have repeating digits upstairs here. But let's take it out to some particular position. At least we need to divide through this whole 1600. So let's do that. We have 9 into 70 goes 7 times. 7 times 9 is 63. Subtract, I get 7 again as expected. And we will continue with that. If I add a decimal and a bunch of zeros here, I would get 0.77777 and so on, and I would have to round at some point. But another way to express this is like this. Another way to do it is to say, well, I've got a remainder of 7 and a divisor of 9, so this is 7/9. All right, so now what have I figured out? I have figured out that this replaces the 16 over 9, and I just tack on the percent sign to what I have right here. So it's 177 and 7/9%. Let's write that over here. 177 and 7/9%. And it would be okay to round it to, let's say, the nearest tenth or the nearest hundredth or something like that, and tack on the percent sign. 2 1/6, same idea. It is 2 1/6 times 100%. Let's do that over here as well. So it's 2 1/6 times 100%. We'll think of 100 as 100 over 1 for multiplication purposes. 6 times 2, 12, and 1, 13. So we have 13 over 6 times 100 over 1%. And now let's see. I see that both of these are even, so they're divisible by 2. 2 into 6 goes 3. 2 into 100 goes 50. Now let's go straight across. 50 times 13. Well, I could grab my calculator here. Maybe I can see through it. But if I can't, I want to come out to the side and do something like this. 13 times 50. 0 times these will give me a 0. 5 times 3, 15. 5 times 1, 5, and 1, 6. So that's 650. So 13 times 50 is 650. And 3 times 1 is 3. And this is a percent. Aha, improper fraction, we don't want that. We'd like to change this. So let's divide 3 into 650. So 3 into 6 goes 2. 2 times 3, 6. Bring down the next digit. 3 into 5, 1. 1 times 3, 3. Subtract, we get 2. Bring down the next digit. 3 into 20 goes 6. 6 times 3, 18. Subtract, I get 2. Remainder over divisor. So we have 216 and 2/3%, you see, for 2 1/6. 216 and 2/3. Let's write that in. 216 and 2/3%. All right, that's all there is to it. Consider this problem. Is 1/2% the same as 0.5 or 5/10? If not, what is the difference between 5/10 and the decimal equivalent of 1/2%? Well, don't be too hasty in making up your mind about this. Think about it this way. We know that 1/2 is equal to 5/10. We know that we can change the fraction into a decimal, and this is what the decimal is. Well, it must be the case that if these two values are the same, then we can just tack on a percent to each one of them. If they're the same, then their percents are the same, you see. So 1/2% is really equal to 5/10%. So to answer the first part of the question, no, 1/2% is not the same as 5/10. Now let's think about the other part of the problem, and we can begin our thinking by changing the 0.5% into a pure decimal, and we do that by moving the decimal point 2 places to the left. So 1/2% then turns out to be 0.005. Now, what's the difference between 0.5 and, well, what's the decimal equivalent of 1/2%? Oh, that's this down here. So what's the difference between those? Well, we can say it this way. Fundamentally, the difference is that 0.5 is 5/10 and 0.005 is 5/1000. That's the difference. But another way to think about difference is in terms of mathematical difference, or the difference in the numerical sense. That means that we need to subtract them. Take the larger of the two numbers, subtract the small one, and we get the difference. To do that, we'll need to add a couple of zeros here, and then when we subtract, we find that that difference is 495 thousandths.